Okay, so let me give you guys a procedure for measuring how tall things are. Okay? So this relies on some assumptions that are not good assumptions. Okay? So I want you to know that everything that I'm about to say comes with one of these. Cool? This whole thing is an approximation. So the idea is you have an object. Like a little blob of rock. And you would like to know how tall this little blob of rock is. What do you mean, what is that?
It's a person.
With the parachute.
Can you draw?
Okay.
I thought it was a flying squirrel, so I got flying squirrel.
I thought it was like a little sparkle.
Yeah, I thought that was a double rock.
Oh, yeah.
I thought you were just trying to draw.
Yeah, see, it's a
Okay.
flying squirrel.
Okay,
Draw some feet
sure,
on it.
it can be a flying squirrel. I do not give one shit
Wait,
about
sure.
what it is.
That's a person? What is that?
So the technique is this. I would like to know how high this thing is.
What is that thing?
Doesn't matter.
That's pretty funny.
It matters to me.
Okay.
It's weird.
It doesn't matter what the thing is. This technique actually gets used for measuring how tall mountains are and some other stuff with a little bit more robust technique. Okay. But what we're going to do is we're going to assume that you can get to the base of it. And you're going to come out here. Okay? So you're going to get a couple measurements. You're going to use a protractor to measure the angle off horizontal to the thing. Cool. And we're going to assume that this makes a 90. This is a what kind of assumption? A really shitty assumption. You guys okay with that?
Mm.
So this first day, we're going to do this one. I'll outline the other techniques so we can just go play tomorrow or Friday. But there's another technique here. So we're going to assume this right angle, which is bad assumption. And then we're going to measure this distance here. So I'm going to call this distance D for kicks. Why would I do that?
For kicks.
For kicks.
Are we actually going to attempt to measure that?
Yeah.
And when we go outside?
Yeah, so I've got a 50-foot tape for measuring tall things, and we've got some assorted like 10-foot tapes for measuring relatively short things.
Oh, okay. Where do they stop for mountains? Or when do they
Mountain.
like when you said they measure mountains with this technique?
So would you
Yeah,
just
I'll show you the
measure
mountain
this?
one in a second.
Oh, okay.
So this is the like close object one, and this is a bad approximation most of the time. So you do this, and then you want to figure out how tall this blue thing is, right? Okay, so do you know enough information to figure out the blue thing?
No.
I think you probably do. What do you know about the blue thing?
It's
Yeah, it's over here, right?
It's D times the
So it's the opposite side of this triangle.
D sine theta
Close.
plus
Which sides do you know on this triangle?
D.
You know D, which is the adjacent side,
Oh.
and you're looking for the blue
Oh,
thing,
Oh, tangent.
which is the opposite side. Well, almost. There's some
Tangent theta.
fudge here, right?
X over D.
so is it
Tangent
tangent
times
theta?
So I know tangent theta is
X over
the
D.
like question mark over D,
Yeah.
and of course question mark is not quite the whole thing.
Yeah.
You guys see that?
You would just subtract your height or add your
Good.
height.
So if this is some kind of displacement h, right?
Yeah.
Then you just add your h. You guys all see that?
Yeah.
Okay, so the height of your object is going to be d tangent of theta. Oh, h was a stupid variable. Let me call that something better. Let me call that p for person. Thank you. You guys all good with this?
Mm-hmm.
Okay, so this is the close-in dumb one. Cool? Check. Questions, concerns, deals. Mm-hmm. Mm-hmm. Okay.
It's not a race.